Okay, so this is your triangle congruence theorem worksheet. You'll notice that these are the 3 new ones, and I gave you the page numbers where like the proofs are. So if you want to go look through the proofs and kind of see that reasoning there, you can. They use congruence transformations to show you how these things are congruent. But we're just going to use them here. So we've got side, 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 angle, side, angle, and angle, angle, side. These are basically the minimum amount of information you need to know about 2 triangles to be able to say they're congruent. Remember that we have one other one that we already did, right? Which was SAS, the side, angle, side. Okay, so that's another one, side, angle, side congruence theorem. And what is not a theorem is angle, angle, angle. That will not give you congruent triangles necessarily. Now you can have 2 triangles that are congruent and they will have 3 congruent angles, but it doesn't work the other way. Just because they have 3 angles in common doesn't mean that they have to be congruent. Okay, this one, again, angle side side is not one of them. Okay, and then also SSA is not one of them. Okay, so let's take a look at some of these and see if we can use these theorems. So the directions say, for the exercises below, determine if there is enough information to say the 2 triangles are congruent. If there is, state the theorem or theorems, so it could be one or more than one, that you would use to prove it. So let's take a look at this guy. Okay. Now this is the list that we can choose from. SSS, ASA, AAS, or SAS. And remember, the order is important. Okay. So let's look at this guy. Well, this side's congruent to this side, and this is congruent to this side. So like right as it's written right here, we need one other side or another angle or something to say that these are congruent. So we have to think about ways to do that. Okay, in this case, notice that these 2 triangles are sharing a side, which means, and since the reflexive property of congruence is that that side is congruent to itself, what we really have here is side angles, or side, side, side. So there is enough information. We have to like read a little bit into it, but the 2 theorems we're going to use are, we got reflexive prop of congruence, which will give us that 3rd side, and then we can use side, side, side. Okay, well, that's how we're going to do that one. Okay, let's take a look. Excuse me. Let's take a look at number 2. So same idea, right? We have this side congruent to itself, so we can say by the reflexive property, this side's congruent to itself. Does that give us enough information? Well, that will give us angle, side, side. Right? Angle, side, side. Is that one of our congruence theorems? It is not one of our congruence theorems. Or you could be like, oh, that's side, side, angle, right? Again, side, side, angle is not one of our congruence theorems. We don't actually have enough information to say that these guys are congruent if this is all we have. There's other stuff that could be going on here, different angles that we could have. So we can't say that these are congruent unless there's another way, and I don't see anything else that will indicate that there's other angles that we have or anything else like that. So we have to say, not enough information. Okay. All right, let's take a look at number 3. Okay, so number 3, we got 2 angles. Okay, so it looks like we need some other information. Now, one of the other things we can kind of read into this is we can talk about our vertical angles here. So vertical angles is, like we know those 2 things are congruent because of the way the figure is set up. Vertical angles are going to be congruent from the vertical angles theorem. So I would say we have angle, angle, angle here. Is that enough? Nope. Is there any other way to get a side? Not really with the information we're giving. So this is not enough information. Okay, let's look at number 4. Similar setup. Okay, so we have vertical angles. But in this case, we have 2 pairs of congruent sides. So we got side, angle, side, congruent to side, angle, side. Okay, so that's cool. So what we can use on this one is vertical angles theorem. That will get us the angle we're after. And then we can use side, angle, side congruence theorem to show that they're congruent. Okay, so what you're going to see a lot here is you're going to see a lot of vertical angles, and you're going to see a lot of reflexive property. Okay, so they may not mark the things that, you know, are obviously congruent. Like in this case, they didn't mark those angles for you. But again, we're assuming that you know the vertical angles theorem, so they don't have to mark them because you know that those angles are congruent by the vertical angles theorem. So there is enough information if you know the vertical angles theorem. You just got to say, hey, I'm going to use that, and then I'm going to use this. So it's not quite a proof, but it's kind of like the middle steps a little bit. And then here again, we use reflexive property to get side, side, side. So look for vertical angles, look for reflexive property that you can use. So you can use reflexive property here, you can use vertical angles here, okay? Now that may or may not give you enough information, right? Because like right here, we used vertical angles and we still didn't have enough information. And right here, we used reflexive property and we still didn't have enough information. So you may not be able to get all the way there, okay? But you have a couple here, and then you have a few here, okay? So list out the information that you know, add it in, and then see if you have the right information to be able to prove that things are congruent. Okay. All right. We're going to do a couple proofs, and this is basically the same kind of thing. We're going to try to prove two triangles are congruent, except this time we're going to do it in a more formal proof instead of you just kind of looking at it and being like, yeah, I can see this and this. We're going to still do that, but we're going to be a little bit more formal about it. Okay. So let's take a look at number 11. And let's see what we have to start out with. So we have AD parallel to EC. And notice that they're marked parallel by those red triangles. All right, that's cool. Parallel is going to be important. And then we have BD congruent to BC. So BD congruent to BC. Okay, great. So those are congruent sides. And we want to show that ABD, this guy, I'll make them different colors. We want to show that the shaded triangle is congruent to the not shaded triangle, EBC. Okay, so what we need to show is there's a couple of things we can do here. We can try to show it by SSS. Okay, we have one side congruent. We'd have to have two other sides, but there may not be a way to get there. We could try SAS. Again, we'd have to have two sides and an included angle. We can try AAS. So two angles and a side, and then we could also try ASA. Any of those four things we'll be able to we can use to prove that these triangles are congruent. Okay, so we got to figure out what we have. Let's make a plan, and then we'll list it out. So the first thing we want to think about is there any reflexive like sides that are being used more than once? In this case, it doesn't look like it. That would be more something like this, where two triangles are sharing a side. But these two triangles aren't sharing a side, so we can't use reflexive property. What about vertical angles? Do we have something like vertical angles going on? Yeah, we do. We have vertical angles right here. Okay, so we know the angle ABD is congruent to angle EBC. Okay, so that's a vertical angles idea. So we're probably going to use that. Let's write that down as a justification. We don't know where it's going to go yet. We're just kind of like brainstorming. Okay, let's talk about this parallel for a second. How does that help us, right? None of these have parallel in it. We want sides congruent and we want angles congruent. So what are we going to use parallel for? Well, let me move the figure and maybe make it in a way that's a little bit easier to read. Okay? Whenever you see parallel, you should be thinking alternate interior angles or corresponding angles, right? All those parallel line theorems we talked about in one of our previous chapters, as soon as you have parallel lines, all those things come into play. So we got parallel lines, right? And they're cut by a transversal. So what can we say? Alternate interior angles are congruent. So this angle is congruent to this angle because those are alternate interior angles. Actually, let me mark them with because I already used an arc there. We also have another transversal. We got this transversal. So we could also say that this angle is congruent to this angle also by alternate interior angles if we wanted to. Okay, so let's go add that to our list. Okay, so if we use alternate interior angles and if we use vertical angles, we can get, there's a couple options. Like I can have angle, angle, side, or I can have angle, side, angle, right? There's a lot of options here. So I have maybe more information than I need at this point. I think I'm going to do angle, side, angle because that will require me to do less writing. If I want to use, well, I can do angle, angle, side here as well. But I don't want to use the alternate interior angles theorem more than once. You can, but like you don't really need to because you have these vertical angles as well. So there's more than one way to prove this. You could ignore the vertical angles and just do angle, angle, side if you wanted to. It doesn't really matter. But I think let's use the vertical angles and let's use alternate interior angles both. So if our plan is to use like this angle and this side and this angle, and that would be angle, side, angle. So let's just throw that down. That's our plan. We're going to use angle, side, angle. And that's going to be our last line in the proof. Oops. ABC. Okay. Our first statement obviously is our given. Okay. Now what we got to do is just state how we're getting the other angles and sides so that we can use this. So I probably have too many lines in between, but who cares? Let's keep going. All right, so the first thing I'm going to say is the vertical angles thing we talked about. So angle ABD is congruent to EBC. How do we know that? Vertical angles theorem. Okay, cool. Now we can choose either this angle pair or this angle pair. It doesn't really matter. Let's do this one. So angle ADB is congruent to, so this one, this guy right here, is congruent to ECB, this guy. And how do we know that? Alternate interior angles theorem. Okay. Now, if we're going to use ASA, we need to make sure that we have all three, angle, side, and angle. So where is the side coming from? Okay, side is coming from the given, BD congruent to BC. Okay, so that's taken care of. Where is this angle coming from? That's this guy, right? ADB congruent to ECB. That was this statement. That was our alternate interior angles theorem. Okay, where did this guy come from? Well, that was our vertical angles. So we got an angle from vertical angles, we got an angle from alternate interior angles, and then we got the side was given. So we have ASA, right? This is ASAA. Now the order that we write them in doesn't necessarily have to be the order they're in the figure. So this looks like, you know, SAA, but it's really not. It's, you know, in the figure it's ASA. We got them all? And we're good to go on that one. So, pow. Okay, this one's going to be really, really similar. So I would highly encourage you to stop the video here and see if you can do this one on your own. The more that you can do it on your own, the better. This is just the more practice you get in proofs, the more your intuition will grow for how to do them. So if you're just writing down what I write down, that's cool. That'll give you some experience. The more you can do, the better off you'll be, the more ahead you'll be for next year when you're going to be writing lots of more proofs. Okay. Okay, let's take a look at what we have and then make a plan and then we'll write our proof. So we got parallel again, HF congruent to GK. When you see parallel, this should be like ding, 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 alt interior angles when you're talking about triangle proofs. When you see those parallel lines, that should like light up in your brain. Cool, you know what you're doing. We also have right angles. Okay, we know that all right angles are congruent to each other, and so that's going to give us a congruent angle as well. Okay, so let's kind of go through and see what we got so far. So these guys are parallel, but we don't know they're congruent. They're not marked as congruent. They don't tell us they're congruent, but we do know they're parallel. So let's switch it around like this because this is how we're used to seeing it. Okay, so we got parallel lines cut by a transversal. There's our transversal. Okay, so let's identify the alternate interior angles. This guy and this guy, right? Now we could also say this big angle and this big angle, but that kind of goes outside of our shape, and so that doesn't really help us out. So there's two pairs of alternate interior angles, but we want the ones that are actually angles in our triangle as well. So these guys have to be congruent to each other. Okay, what else we got? Alt-int angles. Okay, we got the right angles congruent to each other. So all right angles congruent. That's Euclid's fourth postulate. Okay, so those are congruent. And we also have the two triangles sharing a side, which is reflexive property of congruence. Okay, so let's see what we got. We got angle, angle, side. AAS, which is one of our choices here. So we can use SSS, but we can't use that in this case because we don't know anything about the other sides, and there's not really any way to get there. We could do SAS. Again, we only know about one side. We don't know that these are congruent. We just know they're parallel. Same thing here. So we can't use that one. We can use ASA. So if we wanted to, we know that these two angles now are congruent, because if two angles of one triangle are congruent to two angles of the other triangle, then the third angle of the triangles also have to be congruent because they have to add up to 180. So we could potentially do that, but that's more work than we need to do, because right now we got AAS. Okay, we can't do this one, we can't do this one, and we can't do this one. So these are not options that we can use. This looks like the one we're going to go with. Okay, so let me give you a couple hints here. Last line, is going to end up with AAS, because the last line we want to do is we want to prove that the triangles are congruent. Okay, first line obviously is going to be this one. Okay, so all you got to do is these three justifications. So alternate interior angles will give you this angle congruent to this angle. Make sure you name them right. So FHG is congruent to KGH. How do we know? Alternate interior angles theorem. Okay. We also know that all right angles are congruent, so we can say that angle F is congruent to angle K. And then reflexive property is HG congruent to GH. Now, let me help you. I'm going to write that one out for you and explain a little bit. So GH is congruent to HG. Now you might be thinking, well, hey, hold on, the order is wrong. Well, if you think about like this angle right here, this angle that has a vertex at H corresponds to this angle that has a vertex at G. So in our figure here, E maps to K, or E corresponds to K. H corresponds to G, and then G corresponds to H. I know that's kind of weird, but just the way that the triangle's oriented. So the guy that's using H as a vertex here is congruent to the guy that uses G as a vertex here. So this is kind of how your statement goes. So if you're, doing that, that's why this statement looks kind of funky. But this is still the reflexive property of congruence. Right? It doesn't matter how you read it, H to G or G to H. It's the same. It's going to be the same measurement. All right. So put your given in there. You can do that. Here's this one. That's going to give you a side. Okay. And then your two angles are going to come from these two guys. So that's going to be your next two lines. So you're going to have an angle and an angle. This one is an extra line. You're not going to need that. And then you'll have it. So you have all the reasoning. You have the other theorems that you're going to use right here and right here. You just need to be able to state the angle that you're talking about and why, fill it in, put your given, and then you have it all done. Okay. Okay, so that should help you out with this assignment. We did most of it. I just want you to be familiar with those theorems for next year, so that when you start them, you're not behind. You know what those are. You don't have to act like you never heard them before. So yeah, and that's the last one. So wrap that assignment up, get it in, and then we'll start reviewing in a couple days.